Hello, welcome to our Predictive Analytics in Insurance webinar. My name is Katrina Adams, and I am the Practice Lead for Predictive Analytics at LPA Software Solutions. Our agenda today is going to cover a number of topics, starting out with a brief introduction to the general topic of predictive analytics. Then I will talk about specific use cases of predictive analytics in the insurance space, followed by a demo of the IBM SPSS modeler software to demonstrate use cases of predictive analytics in insurance. I'll come back, summarize what we've learned, and I will answer any questions. I encourage all of you to answer questions in the chat window, and it will be those questions that I will answer at the end. So what is predictive analytics? There are many definitions of predictive analytics, but I particularly like this one from Gartner. It talks about connecting your data to effective action by drawing reliable conclusions about current conditions and future events. So consider the vast amount of data that you have in your environment. Being able to see the patterns in that data to help you make some decisions about different business processes is enabled by using the tools of predictive analytics, and we will see that in this webinar. Start by framing where predictive analytics lies in the overall analytics maturity curve. This little diagram that I have here has a past, present, and future data along the x-axis and business value going up the y-axis. Starting at the bottom left, reporting is all about what happened in the past, a true rear view analysis of your data. An example of that could be an analysis of your sales data for 2014. How did your sales rep perform by quarter in different geographic regions for different products? All using past data. Analysis and monitoring answers the question, what happened? What's happening now? This is leveraging present data as well as your past data. And oftentimes you can see this by way of a dashboard, maybe where your executive has his or her hands on the pulse of how your company is performing right at the moment. Predictive analytics moves up the business value, leveraging your past and your present data to help predict what might happen in the future. Imagine if you could predict which of your customers are likely to move to another insurer, and that you were able to prevent that, what impact that would have to your business. Imagine if you had a marketing campaign where you knew which of your prospects are most likely to respond. You could improve your marketing response rate by a large amount. Prescriptive analytics really takes the output of your predictive analytic models and allows you to make a decision about what are you going to do given all the alternatives. A good example here is if you're predicting which of your claims are likely to be fraudulent, and you have grouped them into those that are highly likely to be fraudulent versus those who are least likely to be fraudulent. Prescriptive analytics would put some business rules and most likely some constraints around those that are highly likely to be fraudulent. Perhaps you would send all of those claims to your special investigations unit, whereas those that are least likely to be fraudulent would be automatically processed. Prescriptive analytics allows you to come up with those business rules and the constraints to manage that. So where is predictive analytics used? And really the answer is across all industries. I've divided them here into customer analytics, operational analytics, and threat and fraud analytics. And we're going to talk about each one of those groups of analytics in the insurance space. The key to predictive analytics, though, is that it gives you the ability to influence key decisions at their point of impact. Great example of that is when you call in, let's say I call in to my insurance agent and say, I've had an accident. A deer ran into my car. I am asked 25 questions by the customer service rep at the other end of the phone. And if that rep has the access to a predictive model that says this particular customer and this particular claim is highly likely to be fraudulent, then there's a set of actions that have to get taken. On the other hand, if this claim is not likely to be fraudulent at all, the agent can say, Mrs. Adams, your claim will be processed and you will receive a check once we've had the assessor out to evaluate the damage to your vehicle. Predictive analytics can really impact the point of impact and consider the customer sat perspective here in my scenario. So let's talk about enabling the predictive analytic process. First of all, you need data. And there's plenty of that to be had, specifically in the insurance business. You need to capture that data. You have a large volume of customer information, customer data, as well as your claim data, subrogation data, and all of your underwriting data. You may well have separate demographic data or have access to it, as well as your interactions on social media, for example, or your interactions between your agents and your customer service rep with your customers. And lastly, you may well have opinions through your surveys so you can understand how your customers are feeling about the service that you're providing them. When you have all of that data, the next thing is you will want to do is to analyze it and make some predictions on various parts of your business for various parts of your business. So you can use predictive modeling or data mining. Text analytics is an interesting one. Consider all of that information that the customer service rep is typing in. And if you could glean out of that your customer sentiment and know which of your customers are likely to want to leave and go to another insurer, consider the opportunity you have to make a change to that before it happens. Social network analysis, looking how your customers are networked with each other and the influence that they might have, as well as the classical statistical analysis. You can then couple this with the business rules and manage your constraints. All of this can be done using IBM software. On the capture side, you can use social media analytics to look at all of the social media content of our world today, as well as data collection for survey analysis and survey creation and deployment. Then on the analyze side, you can use SPSS statistics as well as SPSS modeler. Many of you on this call may have used SPSS statistics through your college education. That is an ad hoc statistical analysis tool, whereas SPSS modeler is a data mining and analysis tool that is intended for the enterprise and really is intended for the use of the business analyst all the way across to your statistician if you have one. It's a very powerful tool, and this is the tool I'm going to demonstrate to you today. Decision management, this is the tool that brings all of these rules together and combines that with your model to enable you to make to act upon the information that your predictive model is providing you. Finally, IBM provides a collaboration and deployment services tool that enables you to combine all of this data together and collaborate within your environment to enable you to manage all of these different analytic tools. So let's talk about transforming your predictive insights in your insurance world. I don't have to tell you, I'm sure, that insurance companies and have access to massive volumes of information. Predictive analytics' goal in life is to harness all of that data to solve particular specific business problems, improve performance, and drive better business outcomes. In traditional analysis, insurers work with a snapshot of both current and historical data. But valuable insights can be obtained, but this is fundamentally a rear view mirror approach. Predictive analytics actually works with the same historical data, but uses algorithms to explore the data in the context of a business issue and discover the patterns and causal relationships. So, for example, predictive analytics can determine which customers are most likely to leave, as I shared with you before. These predictive models are then applied to current or new cases, such as new policy applications, a new claim, or a customer policy that is coming up for renewal. They can use the new data and the historical information to make predictions that guide best actions for each case, resulting in better outcomes within key business processes. There are thousands of data points that are captured in claims every day. Using predictive analytics to evaluate each piece of data versus relying on human intervention is truly a game changer. Let's talk about customer analytics in insurance. The cost of attracting and underwriting a new customer is many times greater than the cost of keeping current customers. So customer retention is a high priority for most insurance companies. With high customer churn levels across many insurance products and geographies, it is critical for insurance to identify your at-risk customers as soon as possible when there is still time to take the necessary action to retain them. By integrating predictive analytics into customer retention strategies, insurers can provide the early warnings to enable them to keep their customers longer and to improve their customer lifetime value. From a marketing effectiveness perspective, you can use predictive analytics to identify best targets and best offers for customer micro-segments. That means that you can have a targeted message for a small segment of your customer base that is targeted to those customers who are likely to respond to your offer with the correct offer, the right offer to the right customer at the right time. Furthermore, you can identify the best delivery channel for each offer and customer to improve that acceptance even further. Predictive analytics give you the ability to be able to micro-target your marketing message in that way. Let's talk about operational analytics in insurance, and we think about the underwriting world. Underwriters are very busy folks. Being able to help them score their risk of their applicants and let them streamline their process so they can focus on those higher risk applicants allows the underwriter to focus his effort in the right place at the right time. It also provides insight into the variables and interrelationship that define risk so that insurers can define premiums and coverage that are best fit for the customer's needs and most financially rewarding for the company. Onto the claims side of things and claims management, predictive analytics can help score claims based on the settlement value, enabling better allocation to those higher priority claims. You can therefore right-track claims, identify simple claims for quick approval, for example, identify those high priority, high value claims, and even more so, identify those claims that are suspicious that need follow-up. Fast tracking claims like this helps improve customer sat and improves your customer loyalty. Finally, agent management. Carriers can analyze agent attributes and use models to predict the most effective ways to increase your agent retention, manage risk, and control costs. Furthermore, by deploying the insights of predictive analytics to the wider community of your agents and your brokers, carriers can provide a powerful resource for growing and retaining customers and improving agent productivity. Finally, under threat and fraud analytics in insurance, we spoke a little bit about this, but being able to identify those claims that are most fraudulent. Think about the claims that come in every day and being able to pick out the ones that are most likely to be fraudulent. Being able to detect new forms of fraud and that learn from your data. So there are all different types of fraud coming in that's changing every day. Being able to leverage your data to learn from that and know what are the new types of fraud. Knowing which claims should go to a special investigation unit. Those folks don't have enough time to investigate all claims. Being able to pick out the ones that they should focus on is a considerable value add. Adding this textual analytics to analyze accident reports, for example, might highlight some indicators of fraudulent behavior. Enabling focus on claims that they need additional review. Package all of that. You can improve customer satisfaction and loyalty by making sure that you're focusing only on those claims that are problematic, not those that are from your customers that are most unlikely to be fraudulent at all. Now we've come to the demonstration part of our agenda for today. And to begin with, I'm going to give you an introduction to IBM SPSS Modeler so you can understand the tool itself. And then we will go through two specific use cases of predictive analytics in insurance. But first of all, let's go and take a look at SPSS Modeler. I'll just switch my screen. You can see, I hope, the canvas here in front of me, this user interface, and this white area is called the canvas. In SPSS Modeler, our goal is to build a predictive model. And we do that by building our content here on this canvas. The content is made up of a set of nodes that are connected together, and each of these nodes lie in one of these palettes: the sources palette, record palette, field ops palette, and so on. If we start with the sources node, and the sources is all about the data coming into Modeler. You might bring in one data file, or you may bring in 128 data files. All of those are handled through these nodes in the sources palette within Modeler. So for example, the database node. If I put this node up onto the canvas, you can see we can open that node by double-clicking on it. And every node in Modeler follows a very similar pattern. There are a set of choices that you have to make regarding that node. and the context, of course. You make your choices and then you hit OK and the node is all set to go. In the sources node, it's all about where the path of the data, where is that path, the data structure. So we may, as I said, have a database. We could have a variable length file like a .csv file. We could have a IBM Cognos BI interface, so we can pull in data from our IBM Cognos BI environment, or indeed our IBM Cognos TM1 Cube. We can also bring in Excel data, SAS data, XML, and so on. Once we've got our data sources in, as I said, we may have one or many data sources. We may well want to merge those data sources. For that, we go to the Record Ops palette, where everything to do with a record is handled. In the case of merging, we would use the merge node, or if all the tables have a similar structure, we may use an append node. There are many different types of nodes on the Record Ops, but the main point here is to remember all of these nodes pertain to dealing with records within our data set. Field Ops is all about handling the columns of data that you may have in your record set. You may want to reclassify, so you may want to change the name or reclassify. You may want to derive new variables. You may want to filter out variables. You can use the filter node for that, and so on. The Graphs node palette gives you the opportunity to draw and look at your data in various graphical forms, from a distribution to a histogram, time plot, and so on. Every one of these gives you the ability to visualize your data and understand that. And that's a very important part in the data exploration phase of a predictive analytic project. Modeling is where the fun begins, and you will get to build a predictive analytic model. And if I look at this segmentation of all here, these are all the different types of modeler nodes that there are. And they're really grouped into 4 different populations within Modeler. The first here is the automated nodes. Now, these are the nodes that IBM SPSS Modeler have to help automate this process of building models. If you wanted to build a classification model and you did not know which is the best algorithm to use, the auto classifier node helps you handle that. It gives you the ability to look at build models against all the valid models. So if I double click that up here, you can see it's connected. I can see on the expert tab, it shows me all the models it would actually build. So as a first timer or an expert, this is a very convenient tool as you start out building a model. It allows you to get started. Get rid of that. Same thing for building an auto-numeric. If you want to build a auto-numeric model like a regression analysis, a cluster. So if you want to do a segmentation analysis, there's an automated cluster, as well as a time series node. The groupings here are according to the model type, so classification type models, anything from a C5 model in a data mining context to a regression analysis in your classical statistical analysis. Association modeling. This is where you want to understand when things might happen together. So the classic example is the market basket analysis when you're at the store, the retail store, which products are bought together. In the insurance space, you may want to see which of your product offerings are bought together so that you can determine maybe we are going to upsell all of these, this population of our customers to the products that they're most likely to buy. Segmentation. This is when you want to segment your customer population perhaps to understand like types. Particularly in the marketing arena, you may want to have a segmented marketing message. So think of your insured drivers. you're marketing to 18 to 25-year-olds is a very different marketing message maybe to those who are 45 to 55. Having a targeted campaign and being able to segment them in that way is handled through this segmentation analysis. Moving through the palettes, then, the output palette is all about looking at the output or being able to see into Modeler where the data is. Probably the most commonly used node here is the table node, where you can just attach a table node to another node and have a look at the data that's in the stream at that moment in time. We'll have a look at some of these other nodes, some of these output nodes as we go through our demo. The export node is the opposite of the sources node. So this is where you push your data back out. Perhaps you've built your model, you've created a score. You would then output that data, whether it's to a database, to your IBM Cognos BI environment, or to an Excel spreadsheet. Whatever your need is, you can export it here. The next palette is the IBM Statistics Palette. If you have IBM Statistics installed on your machine, this is the palette that will allow you to interface with SPSS statistics from within your modeler environment, which allows you to extend the ability of the capability of Modeler to all of those of IBM SPS statistics as well. And finally, if you have SPSS text analytics, this enables you to perform analysis on unstructured data. So think of your customer representatives who are talking to your customers and they're noting in text on that type of conversation. You can analyze that text using text analytics and maybe pick up your customer sentiment from those conversations and know which customers are likely to be unhappy and then be able to do something about that. So that gives you some ideas of SPSS Modeler. We will illustrate that a little more deeply now as we come to our demo cases. So now let's talk about a specific use case in the insurance business. We're going to look at building a model to help us identify which claims are most likely to be fraudulent. To do that, we're going to use historical claim data that we already know have been classified as fraudulent or not. Using that data, we will build a model and then use that model to score new claims that we have not referenced to be fraudulent or otherwise. So let's jump back to Modeler and build this model. You can see my stream is made up of two components. Top half is all about building the model using historical data. And the bottom half is using the model to score some new claims. Let's take a look at the first part to build the model using historical data. We start out with some claims history data, which in this instance comes in through a text file, and we open the source node, and have a look at the different types of information that we're providing. We can take a quick preview of the data, which will show us the first 10 rows of this data, as well as all of the columns of information pertaining to each case. You can see that we have a number of ID type fields and then some demographic fields. And since this is insurance for the automotive part of our business, we're looking at information around the vehicles, how long ago they were purchased, how many days ago since the accident, how many claims this particular customer has had, and so forth. You will notice that the very last column is a column called Is Fraud, and this tells us whether this claim has been categorized as fraudulent or not. Remember, we're using historical data that has already been classified as fraudulent or not. And from that, we're going to build a model so that we can use it for future claims. The preview allows us to look at the first 10 data cases, we can look at all of them, or indeed at any point along the way. A table node lets you look into the data in the stream. So if I run this table node, you will see that I have 5,000 records with the 26 fields as we discussed. And just so that you know that they're not all fraudulent, we can scroll down and you'll see some of them are not fraudulent. In fact, I think they were sorted between fraudulent and not fraudulent. So this is a mix. We can also look to see the distribution of that is fraud field, and we've got a number of ways to do that. We could start out from the on the graphs palette and use a distribution node, and you can see the is fraud field, and we can just run that node, and you can see that 80% of our claims are not fraudulent and 20% of them are. It's beautifully round numbers. This is a demo, and I don't imagine for 1 minute that real life data looks like this. Another way to look at the distribution of your data, and this is a very useful tool from the output palette, it's called the data audit node. The data audit node allows you to have a look at the distribution and the statistics around each of the fields. This is a wonderful tool to allow you to get a better understanding of each element of data that you have. And as you see, as I scroll down, for categorical data, it provides you a nice little bar chart of the distribution and as well as a histogram for the continuous. It also provides you with some statistics associated with each field according to its type. The other tab here is the quality tab, and this is a tab we use a lot to help us handle the whole conversation of missing data and poor quality data, or data that has got many outliers. You may or may not choose to include outliers. It depends on the problem that you have, but they all need to be examined. A demo looks very straightforward. We've done a lot of the work here already, but from a predictive analytic project perspective, a good 60% of the effort in building a model goes into gathering the data, understanding that data, and preparing it for model. Once I've got a good idea of the data content, we're ready to think about modeling. And the first thing we have to do is to make sure modeler knows which field it is we are trying to model. So this type node helps us do that. And you can see that the bottom field here is fraud is set to target. That is the target field. That is the field we're trying to model. All the fields that have a role of input, those are the variables and predictors that we will use to predict that field is fraud. The first couple of fields are set to none because those are system identifiers and they are not meaningful in a modeling sense. So the role is set to none, which means modeler will ignore them when it's building a model. So now to the business of building this model, we've got a number of choices. If I go to the modeling node or modeling palette and I look at the various modeling nodes there are, I'm trying to build a classification model. By that I mean I'm going to predict whether this field is fraud, falls into one of two categories, a yes or a no. So I start and I've chosen the auto classifier node to build this model. If I open that node, you will see it asks me for a lot of questions and we can leave those to be the default. But if I go to the expert tab, you'll see all of these model types that have been checked. That means modeler is going to build all of these models and it'll choose, I think, the top three. Yes, it's going to choose the top three. So if I open the model result, you will see I have 3 models. It has ranked them according to, I think, the lift that we use, which is the quality of the model, or the quality of the model. And then we can choose to use just one, or indeed we can use all 3. If we use all 3, we will create what is called an ensemble model, and it allows modeler to spread those models across all of our data and hopefully get the best results. Now you could ask, well, so is this model any good? How do we evaluate that model? There are a number of tools within Modeler to do that, and the one that I'm going to use today is this analysis node. And what analysis node does, it allows us to compare match the number of records that were classified correctly versus those that were classified incorrectly. So to make sure we all understand what that means, Modeler has predicted whether a particular case is fraudulent or not. But we already knew, because that's what we started out with our historical data. And what this is doing is matching those to see how many times did we match what the history record said. So you can see that 89.8% of our records were classified correctly by the model, and 10.2% were classified incorrectly. And the age-old question of, is this good enough, really comes down to the question of cost. What is the cost to be right, and what is the cost to be wrong? And when building a predictive analytic model early on in the project, that is a question that has to be asked way up front in the project so that we understand the rules at this point in the project. For our purposes, we're going to be perfectly happy with our 89.8% correct, and we're going to proceed to use this model to score our new cases. But before I do that, I want to show you what Modeler has done as an output to that model. It didn't change any of the data, it never does, but what it did do was to add a number of columns at the end of each record. The first one is called $XF is fraud, and the second one is $XFC is fraud. And these are fields created by the model itself, and these tell you what the model says for the results. So the first one says the model predicts this particular claim is fraudulent, and this is the confidence with which it says that. All the way down, it does that yes, no, with a level of confidence. So now you can see we now have a mechanism and a model to score our new cases. So the second part of this little demo is to share with you the scoring mechanism. In this instance, under the scoring, we now have a set of brand new claims. And we want to know, are these claims fraudulent or not? In this case, we have a .csv file. And if I open this and preview it, I want to highlight one very key difference between this file and the history file. In this case, we've only got 25 fields. So if I go all the way to the end, you will see we do not have the is fraud field available. And the reason for that is we don't know whether this claim is fraudulent or not. This is a new claim. And what we want to do is use the model to create that new field for us and give us a confidence associated with that classification. So to do that, just like before, I have a type node as I had above, and I copy the model nugget, as it's called, down here to the score. I connect them all together, and I've derived a new field called a risk level. And this comes from the field ops palette, and it's a derived node. And let me open it so you can see what this is doing and give you some idea of the different types of things you might be able to do here. So this is a new field, we've called it risk. And what we've essentially done is set the field to have 4 values: high, mid, low, or minimum. And the purpose of that is to identify which of the claims are high risk and which of the claims really we don't need to worry about at all. So if I take this first one, for example, a high risk claim is one that the model says is fraudulent, with a likelihood greater than 0.75. That's very high likelihood from our definition. And this is really essentially a business rule that you can change according to your own business needs. Same activity, these are split equally. And the bottom one is when the model says the field is no, it's not fraudulent. Okay? So now what we're going to do is run all of that stream through, and we'll look at the output on the table. So I'll just hit run, and you'll notice it'll run through. Let's see the green arrow very briefly. So we had 5,000 records in our new prospects, our new claims. And now I have these three fields, two from the model and the risk field that I defined. So the model defined those that are, whether they're fraudulent or not, the associated likelihood, as well as the risk. If I run down, you can see they're all at different shapes of risk. I can draw a graph, a distribution chart of that risk to see how that looks. So you can see that 83.52% of our incoming claims are not likely to be fraudulent, while as 8.36% are highly likely to be fraudulent. So you could see a business rule that says for those that are highly likely to be fraudulent, that 8.36% or 418 records, we are going to send those to the Special Investigation Unit. The minimum group, we're going to allow those pass straight through because they're highly unlikely to be fraudulent and we do not need to spend time on them. So you can see that predictive analytics has given us the ability to focus on those things that are most important, those high priority, highly likely to be fraudulent claims, versus those that are not likely to be fraudulent at all. So now coming back to our presentation and summarizing what we've talked about today, having seen a demo and discussed various use cases of predictive analytics insurance, we've talked about improving customer retention and growth and getting an improved response rate on your marketing campaigns, as well as reducing payments and fraudulent claims. We've talked about proactively triaging claims, ensuring the right resources are applied at the right time. In fact, we've just seen that in the demo that I provided. Finally, we talked about being able to improve agent retention and performance using predictive modeling. So let's take the last couple of minutes to answer some of the questions that are coming through here on the chat window. I think there's more questions than I'm going to have time to answer, so we will follow up for those questions via email. The first question here on the list is, do you have to be a statistician to use SPSS Modeler? The answer is no. IBM SPSS Modeler has been designed to be able to be used by anybody, whether it's a business analyst or a statistician. The next question on the list. In our organization, we have many R models. We would like to know, can we leverage those R models within SPSS? The answer to that question is yes, indeed you can. And if I quickly move over to Modeler, I'll show you. On the Modeler, on the Modeling tab, if I look at all, at the very end here, there's a node called R. And that node allows you to pull in an R script, and then you can document it within Modeler and run that model within the context of IBM SPSS Modeler. Last question I think I have time for is, you talked about automated modeling. Are there any tools to help the automated data preparation step? There is indeed. Within Modeler, I go back to Modeler under the Field Ops palette. There's a node called the Auto Data Prep palette. And that node allows you to look at the data and optimize that data and clean that data, at least as an initial step. And it does a great deal of work to help you with that data preparation step. I'd like to thank you all for your time today. I hope I was able to answer your questions and that you got good value from this webinar.